Hello friends. So it turns out that there is a simple and easy solution for question 22 that we solved in the last video. Basically this solution makes use of a theorem, a standard theorem in topology, which is a continuous bisection from a compact topological space to a Hausdorff topological space is a homeomorphism. So this is very important theorem in topology, and it makes the solution of many problems simpler. So you must know this theorem. Okay, so let's see how it is helping us in making this solution simpler. So first, for statement T1 is a proper subset of T2, right? Now suppose 01 T2 is compact. Now consider identity map from 01 T2 to 01 T1. Now this is identity map, so it is a bisection. Also T2 is compact, T1 is Hausdorff, because it is a subspace topology induced by Euclidean topology on R, and R with Euclidean topology is Hausdorff, so T1 is also Hausdorff. So, and also if you take any open set in codomain, suppose U belongs to T1, then F inverse of U is U itself, and since T1 is contained in T2, U belongs to T2 as well. So F inverse of U is open. Therefore, this implies F is continuous. So now we have a continuous bisection from a compact space to Hausdorff space. So by using this theorem, F is homeomorphism, right? Now let V be an element of T2. Now F is a homeomorphism, it means F is an open map. So V belongs to T2 is open. So F of V belongs to T1, right? So F of V is open in the codomain. But F of V is equal to V. So it means V belongs to T1. So it says that every element of T2 is an element of T1. So T2 is contained in T1. So from this and this, we get T1 is equal to T2, and this is a contradiction because we have the hypothesis that T1 is a proper subset of T2. So this is a contradiction. So it means that this cannot be compact, right? So P1 is true. Likewise for Q also, we can show that Q is true using this theorem. So let's just check how we can make use of this theorem. So for Q says T2 is a proper subset of T1, right? So assume that 01 T2 is Hausdorff. Now consider identity map from 01 T1 to 01 T2. Now identity map, so G is bijective, right? Also 01 T1, this is compact, being Euclidean topology, and we just assume that this is Hausdorff. Also let's take one open set in codomain, so U belongs to T2. Then G inverse of U is U because G is identity map. and T2 is contained in T1. So U belongs to T2 implies U belongs to T1. So it means that G inverse of U is open in domain. So this implies G is continuous. Thus, we have a continuous bijection from a compact space to Hausdorff space. So using the theorem, we get that therefore G is a homeomorphism. Now again, since G is a homeomorphism, it is also an open map. So the similar proof to the proof of part A. So now let V belongs to T1. So G of V belongs to T2 because G is an open map. So it takes an open map to an open map. But G is an identity map, so G of V is V. So it means that V belongs to T2. So it means that T1 is contained in T2. So from this and this, we get T1 is equal to T2, but this is a contradiction since we assume that it is a proper subset. T2 is a proper subset, so this is a contradiction. Therefore, this is not Hausdorff. This is false. Our assumption is false. Therefore, Q is also true. So thus, this is a simple proof to question 22. But there is nothing wrong in doing the old school method if you don't want to remember theorems, and if you are fast in computations, then you can always use any method. So the thing is, we just have to get to the solution as fast as we can. So it doesn't matter which method you use as long as you are comfortable and compatible with it. So according to me, you can use any solution, whichever is comfortable for you. Okay, so thank you.